Now we have the area estimation, and what I'm going to do is I'm going to slowly bring you from the very basic to what we are going to do for the day. Now, if you have the graph of y equals to ex, and if you're supposed to have the sketch, I think by now drawing should not be an issue. The graph of y equals to 2e. Okay, the graph of y equals to 2e. Should be in a horizontal line. That is your y equals to 2e. E is about 2.7. You times to 2, you're going to get Alright, the graph of y equals to 2e. It will be something like that. And if we want to find the area between 1 to 3, the lower boundary would be 1, upper boundary would be 3. So the area is given by this. So using your geometry, your area would be equivalent to the area of the rectangle. Which is the width is 2 and the height is 2e. The height is 2e, so you will get the answer to be 4e unit squared. We are finding area, therefore you must have unit squared. That is using geometry. If you were to use calculus, which is the integration, your area would be equivalent to integral 1 to 3 of your function, and it is to the dx. The meaning of dx means respect to x-axis. The border is your x-axis, that's why it's dx. We know from the Wednesday's work, this is a definite integral. Therefore, you will get 2ex 1 3. Substituting the 3, 6 times 3, you will get 6e, minus substituting the 1, 2e, and we do get our answer to be 4e unit squared. This is by using calculus, which is integration. That is by geometry. Moving to a bit more complex graph, 2x plus 3. 2x plus 3, the graph should be something like this. Y equivalent to 2x plus 3. And we still want to find from 1 to 3. So the area bounded under the graph between 1 and 3 to your x-axis would be the area of this. And what would be this area? Yeah. The area is equivalent to the area of trapezium. And to know how to find the area of trapezium, it is half times the width. The width is 3 minus 1, 2. And summation of the two parallel height. So when you substitute 1, 2 plus 3, this is going to be 5, 3, 6, 9. So that would be the two parallel height, 5 plus 9. And you will be getting 14 unit squared. Similarly, if you want to use the integration, that will be integral 1 to 3 of your function of your function. You know this should give you 2x squared over 2 plus 3x. 3, 1. Substitute the 3 in. 9 plus 9, 18. Minus 1 plus 3, 4. We get 14 units squared. So we have both approach. The things, the uniqueness here, both answer the same. Why both answer is the same? Because the geometry, all right, the representation is exactly the same as the area under the graph. Because we have straight line, no issue. Anything straight, no issue. When anything's not straight, then we have issue. Okay, equation of circle. Equation of circle would be generally x minus a squared plus y minus b squared equivalent to r squared. In this case, the center is a comma b and radius is equivalent to r. Okay, center of the circle is AB, radius is R. So example, if I have x squared plus y squared equivalent to 36. Center, hello, center 0, 0 and radius equivalent to 6. Now let's play along with this equation. Rewrite this now. Y squared equals to 36 minus x squared. Next, I can square root this equation. When you square root, you should have plus minus 36 minus x squared. It is not 6 minus x. Don't become super powerful. What does it mean? It means that we have two equations. One is y equals to positive square root 36 minus x squared. The other one is y is equivalent to negative square root 36 minus x squared. The one with the positive, in terms of graphical, this is the upper half. Of the circle, upper half of the circle. Okay, the semicircle, upper half. And here, of course, should be lower half. The upper half or lower half is determined by the sign. Negative means lower, positive means upper half. Okay. So based on this, this equation here, it is actually equation of semicircle with a radius of 4 and is positive. If I were to draw, the graph should be upper half. Okay. That would be negative 4, 4, and origin is 0, 0. So your area using the geometrical shape is equivalent to the area of semicircle. And area of semicircle is given by half pi r is 4 square. You will be getting 8 pi unit square. Okay, 8 pi unit square. Using integration, you will be saying that your area equivalent to integral, because I want it from negative 4 to 4. Negative 4 to 4 of your function square root 16 minus x squared dx. your syllabus doesn't allow you to integrate this. Therefore, you have to depend on the answer above. It is 8 pi. Okay, 8 pi. You can check the answer. If it's come out, you can check the answer using your graphing calculator. So here, if you know that because of the negative, the circle is actually, the semicircle is below the x-axis. Okay, it's below the x-axis. However, we only want from 0 to 4. So 0 to 4, your circle going to be here only lah. It is quarter of the circle below the x-axis, or it's the fourth quadrant. Okay, fourth quadrant. Why is it below? Because we have negative in front. So your area is equivalent to the area of the quarter of the circle located in below x-axis. So that would be 1 over 4 times pi. R is 4. Answer is 4 pi unit square. Okay, if you use the integral, it will be that. Okay, so if you want to find the area, the other approach is the integral 0 to 4 negative square root 16 minus x squared dx equivalent to 4 pi. Okay, leave that alone. What if you are asked evaluate integral 0 to 4 negative square root 16 minus x squared dx? The answer is negative 4 pi, because we are not finding the area. Negative 4 pi in terms of area, what does it mean? It means the area located below the x-axis. If in terms of area, the area located below x-axis. If you're just evaluating regardless area, you keep the negative. Okay, you keep the negative.